Okay, so you asked me to do a quick little video on drawing Lewis dot diagrams. Now, we went over this in class. I know some of you were not there because it was on Friday before vacation. Shame on you. But I hope you enjoyed your vacation. So these are the rules, and we'll go through and flip back and forth and apply them step by step. So we're going to do this on a particular example, and so the example I want to start on here is CF4. So we will do CF4, and going back and forth, the rule first is to count the number of valence electrons for the atoms in the molecule, including the charge. So in this particular molecule, we have, let me get that. So we have a carbon, and we have a fluorine. And then we figure out the number of valence electrons in each of these by looking at which column of the periodic table. And carbon is in group 4A. Fluorine is in group 7. So there are 4 valence electrons contributed from the carbon. But there are 4 fluorines, so we multiply that number times 4, 1 for each of the fluorines. 4 times 7 is 28 valence electrons. A total of 32 valence electrons we have to account for in this molecule. Now that's first step. Second step, place the most electropositive atom, the one that's the least electronegative atom, in the center. Or if there's only one atom, it goes in the center. And then draw a simple diagram, single atom in the middle, one bond to each outer. So we'll start here with our simple diagram. And in this case, that would be a C. This is so infuriating when it doesn't work very well. To one F. Here's another F. And I'm just going to draw these equally spaced around, and then one line to that, if I can get it to work. And then another F, our fourth F down here. And then another F over here, and one line. Now each of those lines represents 2 electrons. So I'm subtract 2, 4, 6, 8 electrons. We've used those up out of our count. So we have 24 more valence electrons to use. Now we go back and look. Our next step is subtract 2 electrons from the total number of valence electrons for each of those bonds. That's why we subtracted 8. And now we satisfy the octet rule for all outer atoms. So we go back to our example, satisfy the octet rule for each of the outer ones. So right now, this only has 2 electrons in it from that one bond. So we have to put 2 more, 4 more, 6 more. So that's 6 there, and that now has 8. And then we do the same thing to all these fluorines. And that's 2, 4, 6 times each of those, so that's 24 electrons, and we have none left then. So we go back to our rules. We satisfy the octet, subtract these from the total, that's 24. Place remaining pairs. Now these, if there were any pairs, they would go on the center atom. We did not have any remaining pairs, so nothing to do there. And then we check the octet rule for the center atom. So we go back here and we look. And sure enough, we look at the center atom, 2, 4, 6, 8. We have 8 electrons there, and that satisfies our first molecule, and that would be our Lewis dot diagram. 1 bond to each of the fluorines, and then we put the 8 electrons or 6 electrons around each of the outer ones to balance to make our Lewis dot diagram. And that finishes CF4. We'll do one more example.